Okay, so this is the file that I passed to you. So for practical one, it was actually an exercise in sampling and sample processing. So when you're doing, is my voice clear?
Yes,
Yeah.
doctor.
Okay, thanks. So when you're working with seawater, when you're doing field sampling, you need to decide what samples to process in situ and what samples to bring back to the lab. You must remember that time is always a constraint because there is always a need to come back to the lab to preserve your samples immediately. So we usually do uh, basically you have to plan your sampling properly in order to get all the things done. Okay. So you can please view the YouTube videos to see how the the equipment looks like and the mechanism of how it works. Then Satchidis, we use Satchidis. So Satchidis is a disc with quadrants, black and white. Then when you lower it into the sea, into the lake, there will come a time when you can no longer differentiate between the white and the black boundaries. So that it will be your Satchidis depth. So Satchidis depth is correlated with water transparency. So it's a good measurement, good measure of how clear the water is. Okay. However, it depends on the observer. So you should use the same observer all the time, because if you change the person who is measuring it, then you may not be able to compare the results, because different people, different persons will have a different level of yeah, their eyesight will have different uh, accuracy. Okay. So for plankton net, depends on the mesh size. The ones that we have is 20 micron mesh size. So we use this to collect any organism that is larger than 20 micron. So Niskin water sampler, you've seen, I've explained how this works. Then Ekman grab coral, box coral also. So if you are going to, let's say you are asked to sample from the lake, okay, then you have stations 1 to 5. So you collected the W1 weight is the weight of the filter. This is the weight after you filter 500 ml, and this is the weight after you uh, this is the weight after you filter and dry. Okay, it has to be dried first. So this is the dry weight of 500 ml of sample after you filter. Okay, then this is the weight after you combust. Combustion at 500 degrees Celsius for about 3 hours. So you'll notice here that after you combust in the oven, in the furnace, the weight decreased from here compared to here. So this is because all the organic matter on the filter will be combusted and be turned into CO2. All the carbon will be turned into CO2. Then what's left is are the ash. Okay, so you can refer to the formula in in your practical schedule to calculate the total suspended solids and also the particulate organic matter. So total suspended solid is this minus this divided by the volume of the sample, whereas for POM it is uh, this size. You can actually upload the assignment onto the Google Classroom, then I will have a look at them. Okay, so this is the one that is maybe different. Okay, determine if it is significantly different from the following criteria. So sometimes when you, let's just say we have measured the lake, this is what we found. We found that the TSS is how many milligram per liter. We found that the POM is how many milligram per liter. Then in every country they have national water quality guidelines or standards or criteria. So which means they will have a limit for all the parameters in the water. For example, the DO, salinity, pH, temperature, copper, E. coli, fecal coliform, etc. A lot of variables, a lot of parameters that uh, that is designated as one of the parameters in the national water quality guideline. Okay, so if once you've done this, of course the next step will be you want to know how whether the TSS in lake is higher or lower. Is it different from the TSS criteria from the
Yeah,
yes?
yeah, it's different.
You checked already. You use the one sample test.
Yeah, yeah. But not sure whether it's correct or not, lah. Because the value you give for the weight is in gram, but we need to convert in milligram, right?
Yeah.
So it's very obvious that there's significant difference, lah. Because
Oh,
all we get is like 9,000 something, 2,000 something, but the criteria is only like 50.
so it's higher lah.
Yeah, yeah.
Can no problem. It's just an exercise to see whether you can do it or not. So once you have done it, you can actually submit your assignment, no? Okay. So you're supposed to use the one-way t-test, one sample t-test. Can you see this window? Pass.
Yes.
Okay, so this is a Mac version. So if you look here at the univariate, they have a one sample test. Okay. Oh, you need to put some data there. I can put some dummy data. Okay, so univariate one sample test. Okay, so if the criteria is, let's just say 5, given mean is 5, so we put 5. So let's just see whether it's different. You can see that the t value is 21.668. Okay, the p is less than 0.05. So the means are significantly different. So what you are getting is significantly different from the mean that you wanted to test against. Okay. So remember, for t values, the negative and the positive sign here does not have does not indicate magnitude. but only indicates direction. It's negative because what you have here is less than the given mean. So if this is, let's just say 0, you can see that it becomes positive. The t-value becomes positive because now your data is higher than the the criteria that you want to test against. Okay, so the positive and negative value for the t is just directional. Okay, doesn't have any magnitude. Okay, so this is how you can do the one sample t-test. Any questions about this?
No, doctor.
Okay, thanks. Yeah, for this is the next practical where here we filter the water. Then the ones that get trapped on the filter is your particulates. Okay. However, the water that passes through the filter, those are your filtrate. Okay. So usually when we are doing uh, marine studies, we are not only interested in the particulates, but we also collect the filtrate. So we'll freeze the filtrate, and when we have time, we will thaw it and use it for chemical analysis. So we want to know the nutrient levels in the water. Okay. So when we're doing field work, when we're doing ecological studies, it is no longer adequate to know what type of bacteria you have, to know how many bacteria you have, but you need to know also the chemistry in the water. This is so that you will understand the patterns that you are observing. So is it high because the nutrients are high? Is the bacteria higher because there are a lot of nutrients, or is the bacteria lower because not enough nutrients? So the variables that you measure, for example, ammonium, phosphorus, silicate, all this can be related to microorganisms. Silicate is usually related to diatoms. The diatoms are primary, is a major primary producer. Okay, ammonium can be related to ammonification, related to bacteria. Okay, so all this can be related to your uh, microorganisms. Okay, so for this, when we are measuring uh, chemistry, water chemistry, we usually use a spectrophotometer. And when you do spectrophotometric measurements, you need to have standard curves. Okay, that is a definite step that you have to do. Okay, standard curves is so that you can that you have a curve or an equation that you can compare against. Okay, so have you all done this? Standard curve?
Yes.
So, you've done it. So you can use Excel to draw a standard curve. You can also use pass if you want to draw a standard curve. So let's try with this. So let's just do one. Okay, so we'll highlight these two columns here, and then we'll say we want to do a, can say we want to plot a XY graph. Okay, so that gives you your graph. Okay. Can even have a line. So it's very straight line. But there's no statistics here, it's only a straight line graph. So usually if you want to know what is happening here, you can actually do a linear regression to get the equation out. So for linear regression, it is under linear, model linear. This is a bivariate. Okay, so you can compare. Look at this. Okay. So now so this is your concentration and this is your absorbance. Okay. So you can look at the statistics. Can you see that this is your slope and this is your intercept. So the intercept is where it cuts at the y-axis. Okay, so from here you can see that, so this is the correlation. You can see that the R squared is very, very high, 0.99996. Okay, so the probability of your correlation is very high also, less than 0.001. So you have a very nice line here, and you have your equations out also. So from there you can, once you have your equations, once you have your standard curve, with your absorbance here, what I usually do is I will write out the equation. So y equals 0.040 x minus 5.17 times 10 power minus 5. So that is the equation for phosphorus standard curve. So then once you have that equation, you can insert the absorbance measurement that you have to obtain the micromolar, which is the y. And then you do the same thing to check against the typical seawater concentration to see whether the concentration from Lake differs from the typical seawater. So has anyone done this?
Yes.
So what's the answer?
You mean for everything?
Yeah.
For the phosphate is the 1.248, 1.198, 1.298, 1.248,
So
and
it's very high, right?
1.73. Yeah.
Like ammonium?
5.129, 5.03, 4.98,
Also high,
5.03. Yeah,
significantly
high.
high. Okay, then
All significantly high.
this one also lah.
Yeah, all
Okay.
around 10. More than 10. Yeah.
Okay, so this is how you can do uh the measurements for to determine the concentration of nutrient concentration in seawater.